Man, there's got to be an easier way. Nice. And there is an easier way, otherwise this would be a pretty short video, and the answer is Arduino. In this video, I'll show you how I wrote the code for this tank. This may not be the best way to write the code, but I think this might be the easiest way for people to understand who don't write code on how to write this code. First, I'm going to show you how I did the bolter. Now, for each bolter, I've actually done this exact same code multiple times. And the reason I've done that is because each and every time that these run through, each one of these different pieces count differently. So I wanted to make sure that I'm not mixing them up. It is possible to run this all in one function. I've chose for simplicity's sake not to. So we have the bolter pin. This is the pin that it's actually soldered onto. We have the fire state, which is what the initial state is going to be, and I have that set at low. That means that the pin will be off to start with, so it won't turn on when you turn the tank on. Now, if you wanted this to turn on when you turn the tank on, you just change that. So now let's look at the actual function. So function's going to go below the code here. What we have here is kind of weird. So in Arduino, typically blinking lights, you will use delay. Unfortunately, in Arduino, you don't have innate code switching or task switching. So it will only run the code from top to bottom, and it won't run any other code if you have a delay in there. So I'm using the millis function, which actually is just an innate thing of Arduino. When you turn the Arduino on, it will just start counting the milliseconds that it's on. So what I'm going to do is I'm going to take the current milliseconds, or current mils, or millis, as I have the variable set up to. I'm going to make this equal the milliseconds that the Arduino has counted. And then I'm going to take that number that I've just made to be equal to the milliseconds that the Arduino has counted. I'm going to subtract it from a specific variable for this specific gun. And this will let me know how long it's been since this code has run. And then if this is greater than or equal to the interval in which I want this gun to flash, then this code will run. I currently have it set at 70 milliseconds, so as it runs through, every 70 milliseconds, this function will trigger. And if my bolter state is low, which means if this is off, then I'm going to switch the bolter state to high, which will turn it on. If it's not low, which is what else is going to do, then I'm going to set it to low. So if it's low, I turn it high. And if it's high, I'm going to turn it low. That just turns it on. And then if it's on, it turns it off. And if it's off, it turns it on. Now at the end here, I'm going to digital write. This is the way you actually write to the pins on the Arduino. I'm going to use the pin number, which is saved as this variable, bolter pin F for the front bolter, and I'm going to change it to the bolter state, which is what I'm running from the high-low here. Now, I skipped over a piece of code, which is actually very important, but it makes a little bit more sense after you've read the rest of the code. So this takes the bolter millis variable and makes it equal to the current mils. That way, next time this code runs, if it has activated, then it will start counting to that 70-second interval, or 70 millisecond interval rather. And that's how I run the bolters. Hopefully you're with me so far. This is pretty intensive. There are a couple more functions that I'm going to go over, but by all means ask questions in the comments, and this should not be the only place you get your Arduino knowledge from. YouTube is a great source for this, as well as Adafruit, so check them out. So that works pretty well for machine guns and things that blink on and off, but we can't really do that with the main gun. I only want the main gun to fire twice. So here's the code that I've written for the main gun. And here are the variables that I've written for the main gun. So the variables are going to go on top. Unlike the machine gun here, where I have an interval, I'm actually using hold state on this one. And what this is going to do is it's going to allow me to make this only fire once per time I run the function that is the fire function. And I'll show you how that works here. So we have our main gun, and I have if the hold state is greater than 0, then I'm going to take the hold state and I'm going to subtract 1 from it. That means that the hold state will effectively run about the number of milliseconds you set the hold state to, because every time it goes through, it's going to subtract it by 1. We're going to take the main gun and we're going to turn it on. And then once this hold state is 0 or less than 0, then we're going to end this and say the gun main state is low, or the main gun state is low. So we're going to go ahead and turn it off. Now, digital write, again, this is just the main gun pin with the main gun state. Just like the bolter, this is basically the exact same thing. And that's really all the functions that I'm using to run the guns themselves. Now there's a couple more functions that I put in here just to kind of protect myself. My fire function ends up running over to a point where one of the machine guns has decided to stay on. I want to make sure that they actually turn off at the end of the fire function. So here's the function. This is my off function. This is going to go ahead and turn everything off. So I have digital write, which is going to go ahead and change the state of any of my pins. And I have the front bolter, the right bolter, the left bolter, and the main gun all just set to low. That will turn everything off and make sure that nothing stays on at the end of a function. Okay, I know this is intensive and kind of boring, but let's remember what our end goal is. That's right. It's going to be cool. Just bear with me. All right. This function is pretty big and looks intimidating, but I'll walk you through it. It's actually pretty simple. I'm going to put this at the top because this is our main fire function that's going to call all of the other functions that's below this. And I know this looks huge. This is way simpler than it actually looks. So what we're doing here is we're going to go ahead and we put first, second, third, and fourth. Those are the different sections. I've actually divided into 4, as most of the things that I've done, I've divided into 4 different parts. So you don't just have all of the guns firing at once and then it stops. We have different ones turning on and turning off at different times. So here we have the countdown time, which I've set for 5 seconds because this is in milliseconds. And we have the counter that I'm going to count off of, which I'm just going to set at 0. And that brings us down to this code here. We have the fire timer is equal to millis. So that's just going to set up the timer to make sure that we're counting off of the current milliseconds that it's been on. And then we're going to take our counter and we're going to make this equal to however many milliseconds it is plus our countdown time, so plus 5 seconds, and this will count down for those 5 seconds. Then I'm taking each of these countdown times and I'm dividing it into quarters effectively. The while function is going to make sure that whatever functions is underneath this is going to happen while this thing is true. So while the fire timer is less than or equal to the first quarter of this, then we are going to take the fire timer and update it to make sure that we're counting off of it. And then we're going to run the right bolter, the front bolter, and then the main gun. Now, the main gun I've put in every single one of these, but this main gun in this instance is actually not going to fire. Once that's done, we're going to turn everything off before we start into the next quarter here. And we're going to change the hold state to 400. Now, this means that for 400 milliseconds, the main gun is going to fire. This is actually where this main gun comes into play. So while the fire timer is less than or equal to the second part of this thing, we're going to run the left bolter, the right bolter, and again the main gun, which will only fire once because of the hold state setup. Hopefully that's making sense to you how that works now. In the third quarter, we're going to run the left bolter, we're going to run the front bolter, we're going to run the right bolter, we're going to run the main gun, which is not going to fire because we only have the off function here. We don't have the hold state being changed. And then in the last quarter, we're changing the hold state again. So this is going to count down and turn on the main gun, and the main gun's there. And then we're going to fire the front and the left bolter. So what this will do is we'll have the right and the front, then the left and the right, then the left, right, and front, then the front and the left. And that gives a nice variation as it runs through this whole function. And at the end of it, I make sure I turn everything off. We're almost done. There's one more function that needs to happen. That function is the button. We still actually need to set up this button. Okay, and I'm going to put the button right here at the top. Boom. So we have the button. It's on pin 1. This is very important to make sure you set up your pins. The button state is going to initialize as high. Now you could initialize it as low or you could initialize it at high. The reason I did high specifically for this is because the soundboard triggers when it goes low. So I want to make sure that this is high, and I've just wired the soundboard and this Arduino to the same button. So when I hit the button, it triggers both the sound and the function that I've written. So we're going to come down here to the void loop. This is where the button is going to be put. We're going to put in the void loop this very, very simple piece of code that just says button state is equal to the reading of the pin. So I'm going to ask the Arduino, hey, what state is the button in? And go ahead and make the button state equal to that state. Now, those of you who know Arduino might be asking a very specific question about debouncing. Hopefully some of you have no idea what I'm talking about and you live in a state of bliss. You don't actually need to debounce in this case. So if button state is equal to low, double equals in this instance means actually equal to or comparative equal to, whereas this will change a variable. Then I run the fire function. And that's literally it. The fire function runs, and then it'll come back here to the void loop, and we'll check the button state again. Void setup is the last little tiny piece of code that really needs to be talked about. All right, so void setup is very important, and this is just pretty simple. This is where you're setting up all of your pins. So here's what we have for that. We have the pin mode for bolter pin right, bolter pin left, bolter pin front, and main gun all set up as output, and this will allow the pin to go high or low. Now, for the button pin, you want to make sure it's input, and that will allow you to actually read something from that pin. And this is important. I put underscore pull-up for this, and the reason I did that is there's an internal pull-up resistor on the specific Arduino that I used, and this will make sure that our button just doesn't randomly go off. Okay, wake up and remember why we're doing this. All right, so here is Tinkercad. Open this up. This is a great way to test all of your code. Here's a bunch of different components you can add in. I just use a typical standard Arduino. It's the easiest way to do it. LED, this is an RGB. There's so much stuff you can do here. It's really cool. Now I'm going to go ahead and open the code window here. I've pasted all of the full code in here. This is all 3 bolters and everything. I'm also going to put this in the description of this video, so if you want to copy out the code, you're free to do so. And if we hit start simulation, nothing happens because we haven't hit the button. If you see, the button is actually connected to this wire here, to pin 1, and over here, this is on pin 1. So if we press the button, you can see the main gun go off, and you can see the bolters go off. The main gun goes off twice. Bolters go through the pattern that we've set up in our fire loop here with all the different wild bits. So that's basically how this whole thing works. Okay, and this is why we went through all of that stuff. Well, congratulations if you made it through that. That was a bit long and dry, but I think at the end of the day, we really did accomplish a cool tank. So if you like what you see, like, subscribe, and thanks for watching.